AI,
generative AI, machine learning, AI, semantic understanding, generative AI.
AI, so much AI. To talk more about AI and robotic arms, we have Dipan here with us to hear how he's going to build the next Dr. Octopus from Spider-Man 2. Stick around till the end of the episode.
How do you control or program behavior of an agent? Like if you look at ants, every ant does something very simple. It's just that when each of the ants do the exact same thing and you scale them up by a million or something, interesting properties emerge. If you have a robot and it's got an arm attached to it and it can actually see the world through a camera, let's say, what's the most fancy thing that you can make it do?
That is very weird. How is that possible? Isn't that like unethical?
Turns out that you cannot solve one problem while ignoring the other problem. If the human-computer interaction barrier comes down, then, like our parents can program advanced AI systems just as easily. It's a fair point that you brought up the last thing. I did not think of it from that perspective. So here's the hardest part. You touched upon an interesting part. The hardest part that I found.
If you had one person you could pick who could join your team as of this instant, who would that ideal person be? Who you would want to be with you on this research journey that you have?
I could pick anyone.
So let's start with, who is Dipan?
So I'm basically the founder of Voaige, and we are a company which is making AI for robotics. But before this, I was this guy who was just like basically interested in, I don't really want to say AI, more like the phenomenon of intelligence. So I guess understanding from neuroscience perspective, physics perspective, systems, then finally the traditional AI perspective. So I'm just a guy who's interested in this in general. And there's been a journey through this, of course, in different capacities, but that's how I would like to describe myself.
Let's rewind to the beginning of this journey then. So where does it begin? Where does the first thing happen that is like weird, that makes you realize that, I might be for this?
There's an interesting thing, the thing that happens in undergrad. There's a lot of robotics in India in undergrad. A lot of guys play with line followers, those kind of things. And back in the day when I was in 2012, that's when I graduated. So this is like probably 2008. You had these robots being built around, and there was a lot of fun, sure. I mean, a lot of effort as well. You put these circuits in, then you got to program this thing. At sab karne ke baad, after doing all of these things, the robot follows a line. Now that was interesting. It was good, but I wanted to do a little more because I was like, I put a lot of effort into this, and if I did something a little more interesting, it'll be nice. It's just that
I remember this robot following a line project. I remember we had it in school as well. And there was this whole big thing of who can get the robot to follow the line with the most accuracy. And then the second thing was the fastest.
Yeah. You see, I mean, I'm not a dish on that project in general. It's just that it's a more focused on the mechanics side of things. I wanted to I was hoping a little more excitement on the behavior side of things, which got me interested into how do you control or program behavior of an agent. It could be a physical agent, it could be a software agent, whatever that is. And just turns out that results in the problem of intelligence in general. So got into swarm robotics a little bit, again figured out that, yes, again, it's the keys in the algorithm as well, that every unit, like if you look at ants, every ant does something very simple. It's just that when each of the ants do the exact same thing and you scale them up by a million or something, interesting properties emerge. It's pretty cool. So there's a lot of interesting things to be discovered in the field of intelligence. I don't think we, of course, understand it completely yet, but it's great. back then, definitely not. This was pre-deep learning, remember? So yeah, that's it. We sort of like got hooked on that. Ignored my courses. I was in electronics engineering, not too much. Don't me ask about a transistor, but yeah, that's when it started.
You know, the weirdest experience happens. So I was an electrical engineer at Purdue University, and we would write like 50 lines of code, 60 lines of code in order to light up two separate bulbs. So if you press this button, this bulb should light up, and if you press this button, this bulb should light up. And that was supposed to give you like, okay, I've now built something with its own kind of structure where I have provided the intelligence to understand the button lighting up with the light, right? Is that it was so stupid, honestly, just doing all of that.
Subscribing to our channel helps us majorly. We can get more people, bigger people, the more you subscribe. So please do subscribe to our channel if you haven't already. Enjoy the rest of the video.
But yes, this networking effect that you talk about, and I see this in human beings, right? So if you think about the evolution of society as a whole, it has relied upon internet. As we have been able to expand our connections and our communications, like this podcast, like this conversation that we are having, because somebody from India can connect with somebody from the US while sitting with somebody from Canada, we are just able to evolve so much faster. And I feel like intelligence works best when compounded, and we've been able to do that so well. And now you're taking us like to the next level with it happening within transistors and that being compounded itself.
There you go. Compounding effect for the fourth episode in a row. We've touched on it in the first 5 minutes of, I think, our last 3 episodes, if I'm not mistaken. And I don't know, in whatever 5 or 6 episodes pre our pivot. So here we are back with compounding, back with the compounding effect. And yeah, it just keeps playing up.
We did have a compounding effect, so I was trying to like add that in.
Yeah, I do. Our script never has it. Our script never has it.
No. No, but great. That's it. But in general, I mean, whatever you guys said was absolutely true. The more amount of information that gets exchanged within a system, the more intelligent emergent behavior, occurs. Yes, but I don't claim to be an expert in that side of things. We mostly work on within agent intelligence, not between or inter-agent intelligence in some sense. But that's
so you're basically
clear.
working on the way the whatever agent is behaves within itself rather than with it in its interaction with others. So you're understanding why something like a particular agent does something the way it does based on its own internal makeup and what within it can sort of controls the behavior.
Yeah, so to be putting it more formally, if you have an agent, you have an environment, you have a goal. Basically, you want to do something. The agent wants to do something in that environment. How would the agent go about achieving that goal? Simply, if you want to put, that's the case. In our case, the environment is physical, the agent is physical, and the goal tends to be some kind of physical manipulation.
Let's give it an example. Can you add things to the definition of your agent, and can you add like a little bit more for someone who might not be as capable of understanding the words like agent?
Absolutely. Basically, make robots do stuff. So if you have literally, if you have a robot and it's got an arm attached to it, and it can actually see the world through a camera, let's say, what's the most fancy thing that you can make it do? So look at the world from the camera, like try to build a model of what's going on, try to understand, where you are, what should you be doing, and execute that with the robot. That's going to change the environment. You just did something in the environment. What should you do next in that case? So that's the iterative loop that we focus on. Physical interactions. It's similar to, of course, I mean, in some sense quite different, but it's in the principle, it's similar to Chat GPT in the sense that in GPT, you give the large language model a goal in the sense of your text or prompt. You sort of prompt it to do something, and it has its environment. It might be open to the internet. It might be open to its own internal world model. but the agent goes around and acts on that goal and provides an output out as well. So it's similar in that sense. It's just the agent is different, the environment is different, the goal, the way you sort of communicate the goal is different. That's it.
So circling back, right,
Yeah,
from making the robot go in a straight line to building Arnold Schwarzenegger's Terminator. What happens after the straight line?
Okay. First question is, do you really want to build a Terminator? But to be fair, there's a lot, right? It's a big question. It's a loaded question. So here's the thing. If you look at AI in the field of AI and machine learning, there's a lot of different subfields in it. First is, there's this thing called, people who might be listening who have some background in deep learning research in general, or just read about deep learning, they might be hearing about this term called low shot learning. How do you learn from few examples? That's something we do as well. How do you do multitask learning? Then online learning, which means I have to learn continuously. There's no training and testing separate period kind of thing. There's thing about computation efficiency and all of this. So if you just do research, you can be happy in one of these areas and publish papers and sort of build a career. That's great. But if you want to do robotics and you build a Terminator, all of those areas have to be sort of like in some sense solved. All of these problems have to be solved within the same system. So the same system has to solve everything else. So that's hard. That's not easy. You have to find one solution that solves everything. And that's typically research is not done that way because it's hard and people have to publish. And, people are not going to take on such a hard challenge immediately. So that's the step. The key goal, the philosophy is, do you want to do research in one aspect and then make that solution do something else and then keep improving? Is that a good, valid option? Or do you want to really be bold and sort of say, we are going to look for that one solution that solves most of these things at the same time? These are different philosophies. So in our case, we try to do the second one. But that has to happen between the line follower and the final Schwarzenegger guy. There's a lot going on, yeah.
See, going back to the whole Schwarzenegger thing, it's a very common thing because of the movie and because of how well it did, that anything you hear about robotics or an advancement in the field of robotics, you're like, shit, Terminator. It's just the, first association that pops into your head, which is why it's such a, commonly used example, I guess. And you being in the field of robotics must have heard this, I don't know how many thousands and millions of times. So we always sort of use that as a yardstick or a benchmark or a, how long until we get there, because when this movie came out, this all seemed like, oh yeah, this is never going to happen. So I guess that's the obsession with the Terminator.
Talking about never gonna happen, what's been holding us back? Why have we not reached there yet?
That's again a nice and hard question. And one of the couple of theories on it. First, it's hard. Secondly, so what I'm about to say can potentially be a little controversial in the sense, because it doesn't dish really, but it sort of alludes to the structure of academia in general. So when you do research, right, there's something that happened in AI actually that a couple of years ago, which is 2014, 15, everything started blowing up. So here's what happens. When you have a lot of research being done, those papers have to be reviewed by 3 people each, and then it gets published. So today, I think last year, I don't know the exact numbers, but it's in the thousands, 8,000 to 10,000 papers being published per conference, and then multiple of them per year. So that many number of papers, roughly times 2 or times 3 is the number of researchers you need in the field to review. Now, why am I talking about systems, right? Because the systemic issue, because we don't have enough people who have a lot of experience to review. these papers. So in 2014, 16, and sort of 18, that era, what happened was that they were calling like first year PhDs to sort of like come in and review papers who do not have a lot of experience in what a fundamentally important idea is. And so there was a systemic problem.
That is very weird. How is that possible? Isn't that like unethical to a great extent?
Unethical. It's sort of like what the conference organizers were forced to do, because if they just got a submission of like back in the day 5,000 papers, and now who's going to sit and review them? They have to provide a decision, right, by a certain deadline. It's not easy to do this. Back before this, you had a couple of, a pool of reviewers who were pretty experienced, but now they had to tap into early in the PhDs. Otherwise, there's not many. Reviewers are always scarce. So if you ask some young guys who just came into the field to review a paper, and about 4 to 5 papers or whatever, some amount within a time frame, they don't have the, I would say, depth or experience in the field yet to sort of take a good estimate of the importance of a particular idea. So they go by numbers. If you're on the state of the art, if you have a number, you're on top of the leaderboard or near the top, it's a sort of like a way to get the paper in. I don't want to say that this is the only problem, but what happened was similar ideas were getting published. Fringe ideas were always compared to something that's working amazingly well in one particular sector, one particular problem, and there was not really allowed to come in. Workshops, which have a low threshold of publications, had these ideas come in. Little more, but it's not easy to get published when you're just talking about some hypothesis in general. It has to be concrete. I believe that's a double-edged sword. It is something that will be useful, but it can also hinder progress for radically new ideas. And so since then, the publication structure has changed. You publish more on the internet. You just like literally put a blog post kind of thing. There's a site called Archive where you can just like put your papers up there, and you don't need to get reviewed or anything. So the top labs or labs, if anyone who puts it on the Archive and it's an interesting paper, they do some good kind of not marketing, but spread it around in Twitter or LinkedIn, they actually get some good traction. So those research ideas proliferate. AI is interesting because the field bifurcated into different categories, and there were research who was siloed into those categories. Turns out that you cannot solve one problem while ignoring the other problem. It's not easy. And those things came about only after foundational models came more into mainstream media. Self-supervision came about, which made it much easier to get data labeled without having human intervention. And so the models keep getting better and better. So it's less expensive for someone to build those models. And then, of course, Chat GPT sort of came about and showed that an interesting thing, that if you were trying to build a legal tech startup before Chat GPT for like about 4 or 5 years, whatever, you could probably get some headway into distribution, but your core tech will be beaten by Chat GPT, even though OpenAI never wanted to build anything in legal tech. So a single foundational model suddenly nullified your years of experience and effort. And this happened with some of my friends. Their theses were not very relevant after this. And that's how the nature of progress is.
I don't know if this is a good thing or a bad thing. Poor researchers. It's a good thing on the larger scale of things. Of course, we are moving forward much faster than we ever have. And I am a big proponent of ChatGPT. We are a big proponent of ChatGPT and AI boom that is happening, although we might not understand the fundamentals as well. But even while coding, I used to always think, why do I have to put this semicolon here? And why do I need to follow these formats? Why can't I just type like I think? Or why can't I just type like I speak? And I think that is the major hurdle that ChatGPT has crossed more than anything else. Like, correct me if I'm mistaken.
No, absolutely. I agree with you. I won't say I'm the best at code myself, honestly. My strengths lie somewhere else. But to be honest, yeah, I mean, you should be able to just talk to a system and the system does what you want it to do. That's what programming sort of should be, just program the system. You tell me how to what to do something. If you need a glass of water, I can go get. You don't need to tell me exactly what to do. Get up, don't fall, walk straight, don't hit anybody on the way. You don't need to tell me all of that, right? So there's a little bit of common sense involved. Plus, if you just give me a goal, I should be able to produce the output. That's how a system should ideally be. So yeah.
Enjoying the video so far? Do be sure to leave a like because that helps us reach more people.
Dude, what you just said takes me back to the initial days of learning programming and being introduced to algorithms. These kind of things, get up, don't fall, go to the kitchen, don't hit anybody or anything on the way. These kind of things you realize only when you actually start writing down steps. I think the very common one was making a cheese sandwich or something like that. And, a lot of people were like, oh yeah, open the fridge, take out the cheese. The person used to take it out and just leave it. Wait, you have to close it as well. You have to add a step to close the fridge. So those kind of things, I remember at, being whatever, I think third grade, fourth grade, very young kids, very fascinated by the fact that, oh, this is how you have to talk to a computer. You have to like dumb things down to a level that is, that even a kid would be like, okay, yeah, this is the thing that I need to be told. And to see now where we're coming to the fact that you can sort of have a system where you talk to it in a way that you talk to each other is really cool to actually have seen, that side of things. And now to see that, okay, this more normal human interaction kind of interaction may actually be a very, very near possibility. So that is very fascinating for me as that's for sure.
Also, it's like that. It's not that binary that go out there and don't fall. It's like our brain, right? Use this signal and then move this muscle in order for your thumb to move this way so that you can grab something. Like that's the level of complicacy we are talking about. And that is just for the thumb to move in like one centimeter in one direction. And now we are just able to give it like a wholesome direction of do this and then it'll just figure it out. Fascinating stuff.
To be absolutely fair, that problem has not been solved yet. The get me a glass of water thing. It's
not been solved, but it's something that we may see happening, very, very soon.
Hopefully, yeah. Hopefully we help with that. But to be honest, whatever you guys are saying is absolutely spot on, which is it is fascinating to see how far we have come. It is not. I mean, I remember the things that you were talking about, Rishit, the algorithm, the lessons in algorithms, and you should do bubble sort or this and that. And of course, those are important for us to get a feel of how to think logically and all of that. Yes, sure. But it always felt like you need a lot of practice to be very fluid in it. And I don't think everybody gets into that level of detail very quickly or enjoys it or wants to be there. But they would still like to contribute to the society. So how do you help them? And yeah, I mean, as you just said, if the human-computer interaction barrier comes down, then, like our parents can program advanced AI systems just as easily. The economy booms a little more. So yeah. It's fascinating.
So you finish your bachelor's, then you go to Carnegie Mellon for your master's. How was that experience? What was your master's like?
I don't think I had a lot of time. That was okay. It was pretty sad actually. Okay, what was great was amazing. It was insanely like explosion of knowledge, and wherever you see that people are doing cool stuff, whoever we're talking to, what are you working on? Oh, I'm working on trying to get some kind of like okay, I can't even come up with a project. There's this one person who had talked about something they were doing in genetic engineering. I was like, that just blew my mind back then, but I don't exactly remember what that was. But the point was, there was a lot going on, but there was also, I think I just took on a lot of load because I was trying to apply for a PhD, And I just took on like a bunch of courses, bunch of research projects as well, because you need recommendation letters. And I wanted to sort of like go use those two years to get some experience there. So I took on more than I can chew. So I don't want to do that again. But otherwise, the experience was pretty awesome. I joke that my actual formal education, in some sense, started here because most of everything that I understand or know about AI sort of like was through Carnegie Mellon. Was not real because back in India, I was mostly on the electronics front, and that is actually helping us now understanding compute hardware a little better and choose hardware a little better. But to be fair, it is an experience, and it was a particularly interesting experience for us because I came in here in 2012. That's when the main deep learning explosion happened with the paper called with the model called AlexNet. The guys in Google right now, but actually I'm not sure. But anyway, the point is, I sort of saw one of the prime centers in AI in the US transition from signal processing to sparse signal processing to SVMs and back in the day for these kind of algorithms that were popular in ML to deep learning. It just slowly started eating everyone.
What's the difference between ML and deep learning? Break it down like very simply.
Yeah, ML typically approaches things from a mathematical formulation, optimization, solution kind of approach. If I have this problem, how can I formulate it a certain way? What algorithms can I use to solve it? Then I get an algorithm after I solve the problem, and I executed that, and it keeps getting better on, let's just say, lower amounts of data. Simpler models. You can run this on a CPU potentially, even. For deep learning, the core ideas and algorithms are still the same. It's just a neural network. You have to scale it up. You train it a certain way, but now your requirements for data are insanely large. You have to have ideally tens of thousands, if not millions of data points, and it's a more engineering heavy field than machine learning. I mean, take these statements with a huge grain of salt, of course, but in general. But now it's gotten a little better. You have tools to play with. But essentially, that's the difference. In deep learning, you typically play with a neural network, which is a certain decent size. And you typically you should have a decent amount of data. And those systems will actually work in general better. But you shouldn't be doing deep learning for all problems, by the way. That's in fact one of our interview questions. When would you use deep learning?
Absolutely. It's to do with the scale of the thing. So you're not going to use a rifle to kill an ant. So you have to understand.
Super cool though.
Super cool and super pointless.
But anyway, guys.
PhD it's like in Hindi we have this word called tapasya, right? So PhD is extreme dedication towards one subject because it takes so long. You have to study 4 years undergrad, then you have like some 6 odd years, 7 odd years, some people 8 odd years to actually complete your PhD. And like, was it difficult at any point? Did you feel like, you know what, let this be, I'm so done, I've just been studying for so long?
You know what, I'm realizing that most of the questions you're asking, and I'm probably starting to start with these negative side of narrative perspectives, but no, to be honest, I would definitely do a PhD again, but every PhD goes through their own thing, man, and it's not different than anybody else's life, honestly. Like, you tend to say something like, oh, a PhD is particularly hard and so on. Yes, it can get hard because financially you are constrained, you are in this thing for a certain number of years, yes. But there are other reasons for something getting hard. Maybe your culture of your lab or your research topics or the directions or the advice of it or the lab fit or literally like how interesting are you finding the problem might not be the case. You're putting an investment, right? So that might not be the same for like 4 years later, even at which point you're about to graduate, but then you still have to have the same motivation. So honestly speaking, yeah, I mean, it can get difficult, but if you if you really like the I would say the field, you will find interesting problems on the way. You'll keep yourself motivated. The same as that. But you got to really make sure you pick the right lab, advisor, the problem, the field, all of that. You got to make sure that you talk to people before you get into it. It is an investment, yes. Do not lie.
The reason for my negative questions is that when people are to make these decisions, they generally, tend to go towards the extreme negative sides first. Oh man, it's going to be so long, right? I want somebody like you who has been through that to tell them it's not that bad. And like, I went through this and I love it. And from here, we'll get to the positive sides of things, right? So your PhD ends and then Voaige. Why Voaige? And what is Voaige?
It's a fair point that you brought up the last thing. I did not think of it from that perspective, that I'm not just talking about my experience, but it's also meant to sort of, if somebody listening, then yeah, it's meant to sort of like thoda calm them down and so on. But you're right. Whenever you're getting into PhD, it is a decision, yes. But truth be told, if you like the overall aspect of doing research, if you're in like awe of it a little bit, let's say, and if you overall are okay with a certain number of years of your life in general, dedicated, like, it sounds like tapasya, sure, but it's not really. It's the freedom that you get to explore ideas at your pace in some sense, and you can develop your own way of doing things.
Are you enjoying the questions we asked the founders? Do you have any of your own? Do be sure to comment them down below so we can be sure to ask them.
No, dude, I completely understand your thoughts with the PhD. My sister's currently in her undergrad, and she's considering doing a PhD in physics and theoretical physics for that matter. So there's been a lot of those kind of conversations happening at home. So I can completely second what Akhil's saying, in that the first instinct you have is always, oh, it's for so many years. And if you're doing this, then you're going to be like, this is going to happen afterwards. So it's really interesting to get a perspective from you as well, because that's just helping me to understand, what kind of a thing is, if I have to contribute to family discussions, it's helping me as well.
So first of all, that's insane. Theoretical physics is pretty, definitely like not an easy place to get into, but if she's doing it, that's awesome. To be honest, I think it depends on your field as well. Something like theoretical physics, you need those years. You need that like sort of safe space to actually get that good at physics, biochemistry, sure. There are certain fields, of course, where this makes sense. In AI, I just don't know if you're going to get your return of investment in that sense. There's a lot of resources out there right now, a lot of great people working on great problems in industry. I just don't know if it warrants like 6 years in AI, because the field is going to move extremely quickly. And academia has some strengths, but industry in AI right now has a slightly bit of an upper edge in some sense, because they have compute, they have data, and they have the talent who has come out of academia to finishing their PhD. So a little more experience in research. So theoretical physics.
Yeah, but as you say, I think the biggest difference lies in that, and what you're saying with your friend's PhD thesis is not being relevant and things like that after Chat GPT. I think that's a very major consideration when it comes to AI. So what do you do, what are you doing to stay relevant or keep up with the way things are moving?
Yeah, that's a good question, actually. Again, I don't want to say something. So here's what, man. You have to choose directions which are even further out. But there's a problem in doing that, because if you choose something that's even further out, you're taking on more than you can chew. So you might not make progress. So what do? It's a balancing thing. It's a balancing act. So I don't want to say, yes, I don't want to say we cracked anything. But my thesis did not focus on an application. let's do face recognition, or let's do this, or let's do that. It didn't focus on that. It focused on the science behind a particular phenomena in the brain and how can that help us in deep learning. So it was more about the science of intelligence rather than an engineering application of intelligence. So I like to think that those approaches and those philosophies would remain more relevant in longer periods of time, rather than working on one particular application. And that's how we are. That's who we are at Voaige as well. Like, that's the philosophy of research we use at Voaige, and I feel like it has served us fine so far. We seem to have an upper hand in certain aspects of physical intelligence, and it has always been on fundamental technologies. Like, we build our own networks, layers. Very few companies do that. For example, Google built the transformer layer, and OpenAI used the transformer layer, had a lot of data, sort of like figured out this massive problem of how do you train a model while guiding it. It's called alignment. They call the alignment. How do you guide it in principle to follow, to solve a goal in a certain way? It's called reinforcement learning with human feedback. They did that massive engineering effort, and then they sort of came up with Chat GPT. But I don't want to say that OpenAI does not do fundamental research. Of course they do. But it came up from, like, not a lot of research that has proliferated in the core technologies behind deep learning. That doesn't happen a lot. So our research tries to do that. We try to be relevant. It's not easy. I'm not claiming that we will be relevant, but that's the fight. That's the game that you play.
It's sentences coming out of words and words coming out of alphabets, and you forming like the fundamental pieces to actually get to sentences. And you guys are working on the alphabets. That's what I understood out of.
Right. So, okay, if I had to put it extremely simply, Transformers and ChatGPT, they work on words. Now, when I say a word, let's say coffee, mug, these are two words. Coffee means something, mug means something. If I type it out, it's not going to change the meaning of, like, coffee cannot be spelled with a K per se. Like, that's an error. Whenever you read something coffee, it's typically going to be coffee and then mug. But they together, those concepts mean something. It's a mug meant for coffee, sure. So there was some, there's composition of concepts there. But with sensor data, that's not the case. The data that comes from your eyes, and I'm actually hearing this, you're listening to what I'm speaking, and you're forming concepts in your mind. You're following my train of thought. But it's not like you're really trying to perceive every single word per se. It sort of happens subconsciously. You're thinking about what I'm saying per se. So raw sensor data, when it comes out, it's extremely noisy, extremely low level. It's not as clean as coffee. If I say COFFEE, it means coffee. It doesn't mean anything else. But in sensor data, that can mean different things. That network, that system has to be quote unquote intelligent enough to see past noise from sensor data and build what you call representations, build an understanding through that noise as you go through layers. This is hard. This is interesting. So definitely LLM models were doing this later part, and there's a lot of research going on. But I feel like this earlier, handling sensor data and going to coffee, like how do I just get sensor data from site and then sort of like go to the concept of coffee? That people might think that that's actually easy. Sure, I get it. But do it in a self-supervised manner on a single GPU for a robot that can learn on the fly new concepts. You see that's that's fun. That's going to be fun to do.
I watched this video about reading, and they talk about how reading is a very, very unnatural thing. Because to read something, basically you are looking at shapes, and you're trying to look at these shapes and make sense of those shapes in terms of something that exists in real life, or in terms of something that doesn't even exist. And you expect that all of these shapes are supposed to make sense to you. Like we look at alphabets and we claim that they are alphabets and this is an A and this is a B, but actually they are just drawings, right? As primitive as we are just drawing two random lines and trying to give it an established meaning. And that's what you get here. You read the word COFFEE and then you are deciding, okay, that is supposed to be coffee. And if I put coffee mug, then that is supposed to be a mug that holds coffee, which has been made with water and heat. Like it is fascinating how our brain works, right? And how deep we can actually think. And now we're trying to make machines think in such a deep manner. So,
I'm sorry, didn't mean to cut off. Please finish your thought.
No, go on, please.
I was just going to say, have you seen this Insta post or something? Maybe it's just a random thing where I saw this post somewhere. They scramble the words of those, scramble the letters of those words and still have the paragraph. You're still able to read it if the first and last letter is still the same.
The same.
Yeah. See, think about it. Why does that work? If you pass that thing for a deep system right now, Chat GPT is going to go haywire right now. So it's not going to work. But it works with us. It tells you something about how our biological systems work. And that's interesting to us. You see, that's interesting. We sort of approach robotics from a cognitive and systems neuroscience perspective. So we ask these kind of questions where if a baby had to, look at this object, they're not going to look at this object from all different perspectives and stare at it and think from it for an hour before grasping it. That's not what they do. So you just like go ahead and sort of learn and explore. And the next time you sort of, in general, you see shapes and geometries and around you, the baby is able to interact with it better. So
the baby's going to pick that up and put it in his mouth.
Yeah.
And then try to taste it. And then realize, oh, this tastes bad. And then never taste it again. And, that's reinforcement. That is reinforced learning. I think that's what it is, right?
Absolutely.
You tap the baby and be like, what are you doing? You're stupid. And then you don't do it again.
So let's going back to what you were saying, this whole concept of intelligence and where we come from and how we perceive things and how we process certain things. So this whole fact that when we start speaking, we know how to say the sounds. Like we're not taught, oh, your ass sound has to come from a certain place or the sound comes from the bottom of your throat. You just you're taught the words and the sentences and the language, but the inherent sounds, you're able to do that. So that in itself is something that we are yet to understand. How are we humans able to generate sounds as something that we inherently know? So there's a lot about the way the human brain works, which we're still unaware of. And then coming to language, and the English language more specifically, again, going back to Instagram and all these people now making reels and things like that, they try to make the way certain English words are, like wait and ate, have like the same sound, but they're spelled in two completely different ways and yet in a similar way. And, there's WAIT is also wait and WEIGHT is also wait. So they're like, how the hell does English work? So for someone who has a different first language and they've not learned English their entire life and they start coming to English and asking these kind of questions, there's also that. So you have to understand all of that. You take all of that into account when you're trying to program something to understand, comprehend language that we as human beings look at as being so normal and something that we use on an everyday basis. So to communicate with each other.
I was going to say, I would love to put some structure to the conversation and exactly ask you what Voaige is doing. Like what exactly is the product or what you are building towards or what exactly it is, because we've not discussed that yet.
I was just looking at my video and I was like, it's 40 minutes. And I'm like, yeah, I've been doing all this like philosophies and so far. Thanks for pulling us back in crowd.
Dude, this is how our podcasts work. We usually end up on one end of the road and then we're like so far down that we're like, okay, wait a second, we have to come back to what we were talking about. And this is why we don't like to do questions and things like that, because it sort of just confines us to that.
All right, so let's talk about what we do. In a nutshell, we build AI vision software with physical intuition. That's how we say it to investors. That's how we say it to customers. Basically, we're building software only. And why do we emphasize that? Because most other companies build some component of hardware. Either they build a camera, They build an end effector, which is the tool that are basically a hand for a robot in some sense. We don't build any of that. We just say we just build software. You have a robot, you have a camera, you have a task to be done. You can just use our software and sort of like program that robot extremely easily to handle all that variation that your task might have. Let's take a concrete example. If you look at the supply chain for all consumer product goods, CPG, or retail or something, or even Amazon, when you order an Amazon box, actually, that's a good example. Somebody has to take the stuff that you ordered from the shelf, put it in a box, tape it, and mail it to you. Who does that? At scale, by the way. You can't just have one person do it. This has to happen at scale. Millions of parcels or shipments happen, within a certain amount of time. But the question is, how do you reduce cost of this? So you can try and automate this. You can try and automate the item coming in from the shelf to some station where somebody could just pick that item up and then put him in the box and tape and all of that. But you see, the idea is that if that is a task, let's say that is a task, now what are we supposed to do? You have a box of items. So let's say I ordered batteries, a toothbrush, and what would you guys like to order? Just quick.
A cup.
Soda and a cup. All right, let's go. There are 4 different things. All of them are different things in this bin. How would you use a robotic arm with a single end effector? Or maybe you can change it. How do you understand where to grasp it so that you don't break it? You pick it up the right way. You package it the right way. You can't put the smallest thing first and then top it up with a board game or something like that. You have to be intelligent about how you arrange these things. Make sure they look okay. Fill the remaining area with bubble wrap, whatever they put, and tape it up, and then send it out. See, how do you program it? Let's say if you want to automate something, you are Amazon. Do you ask your robotic engineers to do it? That might be one way. They're going to go in and actually think about how do we get all the millions of different SKUs. SKUs is a unique code for a product, basically. How do you pick up these different objects and pack them intelligently in this box? It's not an easy thing to figure out. It sounds trivial, but some of the hardest things in computer science sound trivial just because we don't think about it. These are subconscious skills that we have already.
Dude, you're talking about robots having to be programmed to package things in boxes. Amazon, since we're using Amazon as an example, is notorious for even with the current system where humans are packaging things, they give lopsided boxes for different things, and you often come out with a small thing in a massive box filled with just plastic bubbles all over the place, and you have a massive box for a small item or a couple of small items. So we as human beings, and trying to be as efficient as possible, as time saving as possible, we end up often packing things in various shapes and sizes just to save time. So I can only imagine how much more difficult it is to get to program this into a robot and ask it to automate this entire process when we haven't figured it out yet completely perfectly.
And the sheer number of details you would need for the size of the catalog of just Amazon itself. This thing is delicate here, it is not delicate here, which is the basic problem that you mentioned. Where do you hold it? Right? It's crazy to think how many questions you have to ask even of a single object, how much you would need.
Correct, exactly. And if you want to, let's say, think about that problem, that's hard. I'm not going to say we have solved it, but that's the kind of problem we are aiming to solve under 15 minutes by anyone. All they have to do is, hey, I want to pick up in this area and I want to place in this area. Everything else the AI handles. Everything else. Whatever you put in that area, whatever hand you use for the robot, we understand the geometry of it. So we can understand sort of how should you pick up in a certain way? How should you pick up a certain object so that you don't damage that object and you maximize the efficiency of packing in the packing area. That's the kind of software that we are building. Our product is called Deep Space. That's what we're building. That's what Deep Space lets you do. Will be able to let you do. Currently, what it does is given an object, it can pick it up. sort of, we don't need to ask you for data. We don't need to, if it's mangoes, if it's chicken, if it's books, if it's e-commerce items, if it's manufacturing parts, we can sort of pick that up at first go. This is called zero-shot grasping or object manipulation. That would be the sort of technical term for it. But we can handle that. And that's the AI that we've built. That's the foundational model for physical intelligence. That's how we are selling it. It's truly, it is a foundation model though. But the key aspect is, okay, this is the tech that we're building. How do you wrap it around to become a product? What features should it have? Who are you selling to? How can you get massive distribution on this? That's the fun business side of things. Of course, we're happy to dig deep there. But the core idea is for Voaige, given your robots, your cameras, your task, your objects, mangoes, strawberries, whatever you want to pick up, we should be able to let you program that entire task under a few minutes. That's the goal.
Please do share the video with your loved ones. The more you share it, the bigger our circle becomes and the more people we can reach.
I'll ask you the meat question. How do you make money? Have you made money?
We currently, we're a pre-seed stage company. We have runway, of course, until the end of this year. This could be, at which point we'll be raise our seed round. But we have burned about 200K so far. And we have revenue of 80K. So we've been pretty capital efficient. And we've been lucky to have revenue in the bank already. So this is not counting the revenue that we had. That's a $50,000 revenue project that we had before doing all of this, part of the same company. It was a different product though. But the point is, that's us around right now. How will we make money? We will be selling software licenses. To who? To people who build these systems and solutions. The guys who are amazing at putting things together. They buy a robot, they buy the correct camera, they talk to the end customer, they understand the use case, they get the correct conveyors and size, all of that. They do a lot of that thinking and engineering. And they can also buy our software. They are our prime customers. And they will put things together. It will make their life easier. It will let them target harder use cases, new markets, so they can venture into new markets, have to compete less. Since the marketing increases, the number of players can be more distributed, so they have to compete less. And everyone's happy. So the end user's application gets automated, which was previously impossible or really hard to do or expensive. The system integrator, as they call it, that's a customer base. Their life gets easier because it's easier for them to program these things within a few minutes rather than weeks. And sometimes they can't even do this because they have to work with other startups and companies which have raised tens of millions of dollars who work on a particular sector, but they will sell you their software only with their camera or only with their robot system. That becomes difficult because you have to buy the whole thing. They don't want to buy the whole thing. The system integrators want to have flexibility. So we're going to just sell the software license. You can choose your laptop. We want to sell you Windows. That's how you're coming in.
That's awesome. How big a team do you have? Do you have more people going around?
Yeah, we are currently 3 full-time, including myself. Then we are having 2 more full-time joining by end of this month. Then we have about 3 or 4 part-time and about, a bunch of interns who come and go definitely. But right now they're about like 4. Yeah.
Why not get a job out of PhD? Why start a business after 7 years of this? You would have landed like a very nice 150, 200K job, especially in the space, maybe more. Did you ever think about that?
No, absolutely you do, right? I mean, you can't make a decision like this very willy-nilly and not putting in much thought to it. Yeah, it is a calculated decision. I would just reframe the question to why a startup, basically. It was basically because we do not want to do anything else. So startup was the remaining option. It was by process of elimination, actually. So if you go to academia, then it's not easy. It's, I mean, we should be smiling like, yeah, it's not easy. There's supply demand ka issue. So,
Dude, I mean, these are conversations where I have been having so often, thanks to my sister, are currently wanting to do a PhD. That it's just like, I feel like I'm just reliving that right now.
no man, but truly, yeah, it's academia it's not easy to get a let's say a tenure track position very easily, and you need to have a certain pedigree, you need to be in the right circles in some sense, and have very prolific work as well. I don't think that would have been extremely easy. I would have had to spend a few more years in postdocs and probably on. And the other one is you can go into research scientist position. That was the other option for me. That was also really considering. But this was again COVID. So my batch, when we graduated, there was hiring freezes going on all around. And so the next year, when things were going to get a little better, you're going to compete with your cohort and the next cohort. So it's going to be fun. It's going to even double the competition.
Like it was not hard already.
Yeah, like it's easy, right? So yeah, it's gonna be harder. And secondly, when I have this thing where I do want to do research a certain way. I've been doing my research a certain way in my PhD as well. So I cannot do research any other way. Let's just put it that way. I'll be very bad at it. So if I had joined a larger big tech, I'm sure that there'll be a certain amount of freedom there, but I can't grow the team from, I can just hire like 4 guys right now and then like have, those, have that entire team focused on one particular challenge just because I felt like it. I can't move that quickly in a large big tech organization. So
Cutting through all the red tape.
Through all the red tape, green tape, blue tape, black. Yeah, or a bunch of different tapes. Yes. And of course, big tech is going through some downsizing anyway. So they're going some alignment. In fact, one of the companies that we were supposed to work with, called Everyday Robots at Google, was shut down. They were literally doing this. They were doing robotics for home and use, personal environments, or like more consumer environments, sorry. And so it's not easy. It's not going to be easy to focus on your thing. So here's the hardest part. You touched upon an interesting part. The hardest part that I've found right now, and I think we're on it, we are very close, is to align your fundamental research goal with the financial goal for the company. These two are extremely different. You cannot make money by fundamental research. It was hard as hell to find a direction where if you do fundamental research, I can convince my investors saying, we have to do this. You have to do this like trials moonshot idea because we can make this work. If they work, we make money. I had to convince that because we are seeing that in the market. So finding that direction was the hardest part. It took me 2 years. Yeah. That was not easy.
That's amazing, man. That makes so much sense if you think about it as someone who has to put money into something. You're like, why are you researching these core concepts? And you're like, okay, if we get this, then we end up making money. And automatically the thing goes, okay, yeah, sure. Okay, makes sense. The narrative just switches. The narrative switches.
Exactly. You have to put yourself in the position where the only way the orders are coming in. See, the orders have to come in, but only reason you cannot fulfill the orders because that core research has not been finished. So I have to put myself in that position. So now after like, hey, I don't have any other.
I don't have any other way to go.
Exactly. But to be honest, funding for research has always been, let's say, interestingly difficult and transitory, I guess. You have to write grants and you get a certain amount and you are good for a few years. In a big tech company, to scale up your research is going to take a certain kind of traction for it. And a lot of people actually leave the company. Only like about 2 people on the transformer paper that came up from Google are still at Google. Many of them started their own thing, ventures and all of that. So only 2 people are still there. So it's not easy. It's not a environment where you can grow quickly and have that kind of traction. So a startup made most sense. Now you see the reasoning. It's just that this format of a career made more sense for personal goals.
Where are you in 5 years? Where's Voyage in 5 years? Hopefully. Give me a best case and a worst case scenario.
Okay, there's going to be an answer. You're going to be like, why? Sure, man, you can do better. But honestly speaking, I see this as a journey. That's why we have named ourselves Voaige. It's Voaige because it's Voaig, so it's Voyage in AI, hence the AI in the middle. But we don't want to build general intelligence. We want to get there steadily and build amazing products in the middle. So I think this journey is going to be most fascinating. As soon as somebody builds it, the game ends. Then you got to figure out what everybody else does. How do we all survive and sustain? But honestly speaking, in 5 years' time, I think it's going to be very fun. We're going to hopefully have solved a few fundamental research problems in compute hardware, using new kinds of hardware for intelligence, building new algorithms for that kind of hardware. Of course, ideally, a lot of distribution and traction on the customer front, much larger team, much more interesting and not fringe, but deep tech ideas that we would want to try and develop. So we're on the quest to solve physical intelligence and how to get robots to do exactly like we talked about early in the call. I would just like to get there. We would just like have major milestones towards it, but I don't know if I want the game to end.
Fair enough, my friend. Fair enough. So just on an end note, just a one-liner answer or however you want to answer this. So one last question. Since we have spoken so much about research, if you had one person you could pick who could join your team as of this instant, who would that ideal person be? Who you would want to be with you on this research journey that you have?
I could pick anyone.
Anyone, living, dead, anyone.
I think I would say Hinton, Geoffrey Hinton. I mean, that's a long shot, but I like how he approaches the problems of intelligence from the high-level perspective, and then sort of digs deep into the details and comes up with an algorithm. So I like his research perspective in general. There are many other people in the top 10 already, but I've found his direction to be aligned with what we would like to do so far ahead. And so, if he joins, then that'll be a day.